All right, in this new unit, our focus is going to be on nonlinear systems and inequalities. And so this unit is going to use everything that we've done up to this point. We solved systems in Unit 1, we graphed quadratics and absolute values in Unit 2, and then we learned how to solve quadratic equations in Unit 3, and all of those things are going to come back in this one place. So it's a good kind of review unit, put all the ideas together. So we've previously solved systems of linear equations, and we saw that we can use graphing, substitution, or elimination. Systems do not automatically mean two lines. We have learned that we're looking for where two lines cross, but they don't have to be two lines. If one of the equations is nonlinear, like this one here on top is a quadratic, and this one is a line, mx plus b, and this is our squared, so that's quadratic. That's called a system of nonlinear equations because one of the equations does not make a line. And so when we talked about where two lines cross, there's only one possible intersection point. But with nonlinear systems, there could be multiple. So there's lots of different ways that you could get no solutions with different kind of graphs. One solution would mean they intersect at just one particular point, and two solutions would mean that they intersect at two different points. Now, we're only going to look at ones that have 0, 1, or 2 solutions, but this could be extended even further if I have some sort of weird, crazy graph and then another one that does all the, this crosses 1, 2, 3, 4, 5, 6, 7, 8 different times. So it doesn't have to just be limited to 2, but I'm not going to torture you with problems that have 9 solutions. So that's why we'll just be focusing on these for right now, okay? So we're going to use the method of solving by substitution. And this is the same method that we used with linear systems. So the goal of substitution is to solve for one of the variables, get it by itself, and then substitute that quantity in for the variable in the other equation. So a couple of really important reminders when we do this, because these are going to be a little bit more involved than the ones we've done before. Always substitute in parentheses. Always. It's better to put them and not need them than to not put them and then do it wrong because we didn't have parentheses where we needed to. Secondly, we never distribute an exponent. So if you have a plus b squared, that does not equal a squared plus b squared. A plus b squared is a factored form. And remember, we talked about in the last unit that a squared plus b squared is prime. That is not factorable, the sum of two squares. So that's impossible for those two things to be equal to each other. Instead, what is always going to happen is that we saw when we practiced with completing the square that a perfect square comes from a trinomial, so it's got to have 3 terms, and it's always going to be in this form here, a squared plus or minus 2ab plus b squared. Now the plus or minus, you're going to pick plus or minus depending on the problem, so this one might change. This one is always going to be a positive. The first one could be positive or minus, it just depends. And so an easy way to think about it is this little expression, square the first, square the last, multiply and double. I just treat that as like a little chant. So say it to yourself before you go to bed every night. Square the first, square the last, multiply and double. Square the first, square the last, multiply and double. And so what that gives you is exactly what happens when we FOIL this out. So this is your other option. If you forget the shortcut, square the first, square the last, multiply and double, write it out side by side and then distribute. But so here's how that square the first, square the last, multiply and double works. If I have something like x minus 5 squared, okay? Square the first would be x squared. Square the last would be plus 25. That last one is always positive. Now multiply means multiply these two. And it's going to be negative because that's a minus. That's how we choose the plus or the minus. So 5 times x times 2 gives us 10x. So there's the answer without having to FOIL or distribute or anything like that. Let's try another one. X plus 3 squared. See if you can write that down in your head. Square the first, square the last, multiply and double. See what you get. x squared, square the first, square the last, plus 9, bring down the plus, and then we multiply and double. X times 3 times 2 is going to be 6x. They can get a little bit uglier if I have something like 7x minus 2 squared. When I square the first, we have to square the 7 and the x, so I get 49x squared. Square the last, I get plus 4. Now multiply and double. 7x times 2 is 14x, times 2 again is 28x, and we bring down the minus. So that's a really quick way to multiply them out, okay? You will also see equations of circles. Now we can take circles a whole lot farther than this, but we're just going to be working with these basic circles. So if I have x squared plus y squared equals r squared, this will be a number of some sort. R is the length of the radius. So for example, if you see an equation like x squared plus y squared equals 4, that would mean that the radius is equal to 2. And it'll always represent, and you don't have to know this, but it is helpful to have in mind as you're working, a circle that has a center at the origin and then a radius of 2. So it would be something like that, okay? In pre-calc and later classes, you'll get to talk about how do you move the center and what happens when you have a different radius, but that's for another day. Okay, so we're going to look at 2 examples in this video, one where we have solutions and one where we do not get solutions, and that ought to be enough to get you started. So on number 1, we have x squared plus x minus y equals negative 1, and x plus y equals 4. Now you could solve either of these equations for either of the variables, except in the first one, we can't solve for x because I have 2 x's. I need to make sure that when I solve, I have one variable by itself and only the other variable on the other side. So that probably wouldn't be a great idea to try and get like this x by itself, because then we would still have an x squared. Don't want to do that. So I'm going to solve the second one, and I'm going to solve it for y, so that way I have all x's in the top equation. So if I subtract x from both sides, I'm going to get that y is equal to 4 minus x. So now I'm going to take this 4 minus x, and I'm going to plug it in for y in the original, or the first equation. So I have x squared plus x minus, always substitute in parentheses, 4 minus x equals negative 1. So you see why those parentheses are so important, because I need to subtract both of these terms, not just the 4. So I have to flip all of these signs. So I get x squared plus x minus 4 plus x equals negative 1. Now, I see that I have an x squared, so that tells me this equation is quadratic. And I also have an x, so square roots is not going to work to solve this. So I'm going to get this equal to 0. So I'm going to combine the x and the x, and I'm going to go ahead and add 1 to both sides so that it's equal to 0. So I get x squared plus 2x minus 3 equals 0. Now we have a quadratic equation, so we're going to have to solve it just the way we did before. So we cannot use square roots. We have an x squared and an x. Let's think about if it's factorable. Does anything multiply to negative 3 and add to positive 2? And yes, 3 and negative 1 does that. And since now we know it's factorable, we want to ask ourselves, is this a shortcut? Yes, it is. This is our a equals 1 shortcut. So these two numbers, x plus 3 because it's positive, x minus 1 because it's negative, those become our factors. Don't forget you're equal to 0. And those are the factors, but remember we're trying to solve for x. So we take each of these factors and set it equal to 0 on its own. That would mean that x has to be negative 3 or x has to be positive 1. So we are halfway done, because remember with systems, we want our answer to be an ordered pair, x, y. We want to know where do they intersect. And so we have the x's. Now we need to take these x's and plug back in. And you can plug it back in to any of the original equations, including the y equals 4 minus x. And that's the one that I'm going to do because that already has y by itself, and y is what I'm trying to solve for. So if x equals negative 3, then I get y equals 4 minus negative 3, which is 7. So one solution is the ordered pair negative 3, 7. That is one place where those two graphs will cross. And then I'm going to do the same thing with x equals 1. I get y equals 4 minus 1, which is 3. So the other ordered pair is 1, 3. Sorry, my computer just glitched on me. We're back. So this is going to be the ordered pair 1, 3. So what that means, I don't know exactly what the graph looks like, but it's going to be a parabola and it's going to be a line, and they cross at 2 points, negative 3, 7 and positive 1, 3. So it's going to look something like that. Okay? All right, let's look at number 2. Number 2 is not as long because it actually does something a little bit weird. And this one is already set up really nice for us. We have y equals x plus 4. We're already solved for y. So we're going to take the x plus 4 and we're going to plug it in for y. Now notice this is one that has to be squared. This represents a circle, the top equation, because x and y are squared, and a linear, a line, on the bottom equation. So when I plug this in, I get x squared plus x plus 4 squared equals 4. This is why that squaring a binomial is really important, because you're going to get a lot of things that are squared here. So we have x squared. To square a binomial, we square the first, square the last, multiply and double. So square the first is x squared, square the last is 16, multiply and double should give us 8x. And that is equal to 4. I again see a quadratic, so probably best to start by getting everything equal to 0. I'm going to subtract 4, and I'm going to combine these like terms. So I get 2x squared plus 8x plus 12 equals 0. And right away here, you might notice that we can divide everything by 2. And that's probably a good strategy. So let's go ahead and do that. If you can divide everything and make your numbers smaller, it always makes your life easier. And so this is what we get. And so now the question is, can I use square roots? No. Can I factor? Does anything multiply to 6 and add to 4? No, that doesn't work. So then we have either complete the square or quadratic formula. You can use whichever one you like, but because A is equal to 1 and B is an even number, this one is really good for complete the square. So that's what I'm going to do. And if I'm going to complete the square, that means I need to subtract 6 from both sides to get it to the other side. In the blank is half of B, which is 2, squared. 2 squared is 4, so we're going to add 4 on both sides. And then something interesting happens. This is x plus 2 squared equals negative 2. What is going to happen when I take the square root of both sides here? We will get x plus 2 equals plus or minus I root 2. Now we're trying to find where these graphs cross, and we're finding that our solutions are imaginary, which tells us that they don't cross. An imaginary intersection isn't there, okay? Since they're imaginary, that tells us that this system of equation has, whoops, I almost wrote no systems, no solutions. And that is because we got an imaginary point of intersection. So that means no solutions. We are only looking for real number values. Imaginary numbers don't live in the XY plane. All right, so that's kind of a weird case that can happen. That would mean that you have no solutions. So substitution is what you're working on for today. And that should be enough to get you started on your assignment.